Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation of a lecture video for subject Electrical Circuits 1, code BEV 10303, and in this video, which is a part 2 video, we are going to continue our discussion on the chapter 3, which is circuit analysis. Okay, so what are the topics that we are going to cover for today is a mesh analysis with the current source, okay, where we are going to see on how to apply the mesh analysis when your circuit contains of current source. Okay, so basically there will be two different cases where the first case is your current source is only exists in one mesh, okay, and then the second case is where your current source exists between two mesh. Okay, so we will see in details later. Alright, so for today topic, okay, for the mesh analysis with current source, basically when you have a current source, it's actually the analysis will be much easier compared to the previous compared to the normal mesh analysis, because the occurrence of the current sources will help you to reduce the number of equation. Okay, we will see in details on how it happened. Okay, so we just go to the case number 1, where your current source exists only in one mesh. Okay, so let's consider the following circuit where you have a supply connected to the combination of resistor, and then you have another current source in the second mesh. Here you have a first mesh, here you have the second mesh. The first mesh doesn't have the current source, but your second mesh has the current source here. Okay, so in this case we consider it as a current source exists only in one mesh, which is the second mesh. Okay, so when you have this, you can see that I2 will be equal to -5. Okay, see, I2 will be flow from top to the bottom, but for the current source 5 ampere flow from the different direction. So in this case, your I2 will be equal to -5 milliampere. Alright, and then once you have this, then you can apply your Kirchhoff voltage law for the other mesh, which is mesh number 1 as usual. Okay, so in this case, you start from this point. Okay, you have a negative polarity here, and then as you know, current flow clockwise from this point to this point. So what you have here is you need to assign the polarity for each of the elements first. So here you have for the passive element, when you have a current, so the potential is current will be flow from the from the higher potential to the lower potential. So that's why you have a positive, negative. Same goes to the 6 ohm. Here you have I1, so you have positive and negative. Okay, but you also have a I2 here. So I2 will be flow on the clockwise like this. Okay, so since the flow of the I2 is like this, so the voltage across here is positive and negative. Alright, okay, and then once we assign the polarity, then only we can apply the KVL. Alright, so the KVL, okay, you start from this point, you see the negative polarity, so that's why you have a -10, okay, and then here the voltage across 4 ohm, here you see the positive sign, so that's why you have plus for I1, okay, because V equal to IR, so R is 4 ohm, the I will be I1, so plus for I1 plus, so the voltage across 6 ohm is given by, here you see the positive sign, so plus 6 ohm multiplied with I1 minus I2, okay, equal to 0. Right, so after that we can further simplify the equation, so that here we have a -10, you bring to the other side, you have +10, so 4I plus 6I minus 4I1 plus 6I1 minus 6I2 equal to 10, right? And then 4 plus 6 will be equal to 10I1. And then now in this case, I2 will be equal to -5. So you can just straight away substitute the value of the I2. So here I2 is -5. So -6 multiplied with -5 is equal to 30. So 30 you bring to this side, you get 10 minus 30. So finally, I1 will be equal to -20 over 10 will be equal to -2 ampere. Okay, so that's it. See, by applying, when you have a current source, you don't need to apply the KVL for both mesh. You just only need to apply KVL for the first mesh only. Okay, for the second mesh, you don't need to apply the KVL because you have the current source already. So based on the second mesh, you just need to come up with this equation. Alright? Okay, next we go to the case number 2 where the current source exists between two mesh. Okay, so let's consider this following circuit. So here you have a first mesh. Here is your second mesh, and then you have a current source. This is your current source, and then the current source exists between the two mesh. Okay, so it exists between the two mesh. If let's say the current source appear here, so that one we consider as a case number 1. If the current source appear here, that one we consider as a case number 1. But in this case, the current source exists between the two mesh. Okay, it is intersect to each other. So that's why in this case we consider as a case number 2. Okay, so what do we need to do when we have this kind of situation? So usually we can exclude this element. Okay, we can exclude the whole branch. Alright, and then finally we can have this. So this one we consider as a super mesh. Okay, because a super mesh is actually a combination of the two mesh. Okay, and we create super mesh by excluding current source. Okay, here is your current source and any elements connected in series with it. So anything that connected in series with the current source will be excluded. Okay, so from here, this is a super mesh. So actually, why do we need the super mesh and why do we need to treat the super mesh differently? Okay, so because for the mesh analysis, as you might know that we are applying Kirchhoff voltage law to do the mesh analysis, right? But when you apply the KVL, you must know the voltage drop at each of the branch. Okay, so you must know what is the voltage drop across here, what is the voltage drop across here, and what is the voltage drop across here. But in this case, because you have a current source, you don't know what is the voltage drop across the 6 ampere. So that's why we excluded the whole thing and then we create the super mesh. Okay, in this case, we have a 20 volt connected to 6 ohm. Okay, you have connected to the 6 ohm, and then you have a 10 ohm here, you have a 4 ohm here, right? Then so you just exclude anything that intersect in between, right? Okay, so the current will be same. Here you have the first mesh current, which is I1. Here you have the second mesh current, which is I2. So here also you have I1. Here also I2, right? I1 will be flowing through 20 volt through 6 ohm, and then for the 10 ohm and 4 ohm, it will have a I2 flow through the 10 ohm and the 4 ohm. Okay, and then once we create the super mesh, then only we can apply the KVL for the super mesh. Okay, so here is your super mesh, and then now you need to apply the KVL to the super mesh. Okay, so before you can apply the KVL, you need to assign the polarity first. So here you have a current will be flow clockwise. So that's why here you have a positive, negative. Okay, here also you have positive, negative, and here also you have positive and negative. Alright, so once you assign the polarity, then only you can apply the KVL. So in this case, you start from this point, you see the negative polarity, so that's why you have negative 20 plus. Here the voltage across 6 ohm will be equal to IR. So in this case, the I1. Okay, so here current is I1, so 6 I1. So here you see the plus sign, so it is a plus 10. So the current is not I1 anymore. Here is I2. Okay, so this side will be have a I2. This side will be have a I1. So here plus 10 I2 plus 4 I2 will be equal to 0. Okay, and then after that we can further simplify the equation. So in this case we have negative 20. You bring to the other side, you have positive 20. So 6 I1, okay, 10 plus 4 become plus 14 I2. So this is considered as your equation number 1. Okay, and then you need to apply the KCL to the node 0, okay, where you refer to your previous slide. Okay, so here is considered as your node O. Okay, so by applying KCL to the node O, you know, here you have a mesh current of I2, right? Okay, here you have a mesh current of I1. So that's why here at the branch current will be equal to the mesh current I1. Okay, here the branch current will be equal, the branch current I2 will be equal to the mesh current I2. Okay, and then you have another branch current. We have a current source 6 ampere here. So when we apply the KCL to this node, so we have the total of current that going in will be equal to the total of current that going out, which is I1 and 6 ampere. So I2 will be equal to I1 plus 6. Okay, so this is considered as your equation number 2. Then you can apply this equation, you can substitute this equation into equation number 1. Okay, so by substitute this equation into here, you can getting I1 will be equal to negative 3.2 ampere and I2 will be equal to 2.8 ampere. Okay, all right. So you see, for the case number 2, what you need to do, you need to apply both. You need to apply KVL for the super mesh, then you need to apply the KCL to the node that connected to the current source. Okay, so for the summary, the current source in the super mesh provide the constraint equation necessary to solve for the mesh current. It means that based on the previous example, you see when you have a current source, when you have a current source here, and then will be connected to the node, right? So based on this, you can have here you have I2, here you have I1, and here you have 5 ampere. So based on this, it can you can provide the constraint equation. Okay, so this constraint equation will be necessary to solve for your mesh current I1 and I2. Okay, and then next, a super mesh has no current of its own. Okay, it means that just now you have based on the example, you have the connection of like this, right? Okay, then you have a voltage supply. So see, it has a super mesh I1 and it has a super mesh I2. Okay, so this is based on the previous example. So it means that a super mesh has no current of its own. Okay, and then lastly, a super mesh requires the application of both KVL and the KCL. Okay, so you need to apply KVL at the super mesh, and then you need to apply the KCL at the node that connected to the current source. Okay, so we will see in details on how to apply those techniques that we had just learned in the following example. Okay, so now for example 3.4, for the following circuit, find I1 to I4 using mesh analysis. So based on the circuit, your circuit will have 4 different mesh. So here is your mesh 1, mesh 2, mesh 3, and mesh 4. Okay, then as usual, each of the mesh will be having its own mesh current. So that's why here you have mesh current I1, mesh current I2, mesh current I3, and mesh current I4. Okay, so you just take note that mesh 1 and mesh 2 form a super mesh, okay, because you have a 5 ampere that exists between the two mesh. So that's why mesh 1 and mesh 2 will form a super mesh here. Okay, and mesh 2 and mesh 3 will form another super mesh. Okay, here you have the current source as well. This one we call as a dependent current source. Okay, so the dependent current source is occur between the two mesh. So that's why mesh 2 and mesh 3 will form another super mesh. Okay, and then because the two super mesh, okay, so the first and the second super mesh is intersect to each other, so it will form a larger super mesh. So the the red dot here represent the larger super mesh. Okay, all right. And then next, you need to apply KVL for the larger super mesh. Okay, so let's move to the solution. Okay, so you can draw your circuitry back. Okay, and then you can exclude those current source. So here, just now you have a current source. You just exclude the current source and then exclude the current source. So this is considered as your larger super mesh, right? So you can apply KVL for the larger super mesh. So in order to apply KVL, first of all, you just need to assign the polarity first. So from this point, you have a I1 flow to this side. So that's why here you have positive and negative. Okay. And then here you have I3 flow through the 4 ohm. So here you have positive and negative. And then the I3 also flow through the 8 ohm here, positive and negative. And then for this case, I2 will be flowing this side. Okay. I2 will be flowing this side. So that's why you have positive and negative. Okay. So for 8 ohm, you also have another I4, which is flow through this direction. So here you have positive and negative. Okay, here also you have positive and negative. Right. So then only you can apply the KVL for the larger super mesh. Okay. So you may start from here. So here you see the positive sign. So that's why you have plus 6 ohm multiplied with I2. Okay. Plus. So here 2 ohm multiplied with I1. And then you go to this side plus 4 ohm multiplied with I3. Okay. And then for 8 ohm, you see a positive sign. So plus 8 ohm multiplied with I3 minus I4. See, through the 8 ohm, we'll be having two different mesh currents. So I3 minus I4. Okay. So equal to 0. And then after that, we can rearrange the equation. So 2I1, okay, 6I plus 6I2 plus, so here you have 4I3 plus 8I3 equal to 12I3. And then here you have minus 8I4 equal to 0. Okay. And then you can further simplify your equation by divide all those terms with 2. So you divide by 2, you get I1 plus 3I2 plus 6I3 minus 4I4 equal to 0. So this is considered as your equation number 1. Right. And then you need to apply KCL at point P. So which one is your point P? So this is your point P. Okay, where you have P. Here you have I2 flow to this side. So your branch current will be equal to I2. And then you have another I1 flowing through here. So here your branch current will be equal to I1. Okay. And then you also, the point P also the node P also connected to the current source, which is 5 ampere. Okay. So you just apply KCL at point P. So you have I2 will be equal to I1 plus 5, because here I2 is the total current that going into the node, and then the total current that going out from the node is I1 plus 5. Okay. And then after that, you need to apply KCL at the point Q. So which one is your point Q? So this is your point Q, okay, where you have I3 flowing through here. So your branch current will be equal to I3. And then you have another I2 going flow through here. So your branch current will be equal to I2. And then you have another current source here. Okay. Right. So your current source is going into the node. So the value of current equal to 3 I0. Okay. So based on the point Q, you need to apply the KCL. So in this case, you have I2 will be equal to 3 I0 plus I3. Okay. And then I0 here, I0 is also equal to negative I4, because here you have I4 will be flowed from the top to the bottom, and then I0 will be flow from bottom to the top. So that's why I4 will be equal to negative I0, or I0 will be equal to negative I4. Okay. So finally, you can substitute this into here. So you can get I2 is equal to I3 minus 3I4. Okay. So this is considered as your equation number 3. Alright, so after that, you can just substitute your equation 2 and equation 3 into equation 1. Okay. So this is the equation 1. Okay, so based on the equation 1, we just substitute the equation I1, which is I1 equal to I2 minus 5. Okay, and then I2 is equal to I3 minus 3I4. Okay. And then after that, here we have I2. So we know I2 is equal to I3 minus 3I4. So that's why we need to substitute I2. Okay. I2 is equal to I3 minus 3I4 minus 5 plus 3I3 minus 3 multiplied with negative 3 is negative 9I4 plus 6I3 minus 4I4 equal to 0. Okay. And then finally, we can just simplify the equation. So here I have 1I3 plus 3I3, 4I3. So 4 plus 6 is 10I3 minus, okay, so here I have negative 3I4, negative 9I4 become negative 12. Negative 12, negative 4 is negative I4 equal to negative 5. We bring to this side, so we have positive 5. Okay, so this is considered our equation number 4. Then, after that, we need to apply KVL in the mesh 4. Okay, as you remember from the previous circuit, so this is the mesh 4. Okay, so before we can apply the KVL, we need to assign the polarity first. So from this side, we have a I4 flowing through here. So here positive, negative, and positive and negative. Okay, but you must remember you also have a I3 here. Okay, I3 flowing through this side. Okay, so that's why you have positive and negative. Right? Okay, so once we have the polarity, then only we can apply the KVL. So from this point, we have to multiply with I4 plus 10. Here you have plus 10. And then plus 8 ohm multiply with I4 minus I3. Okay, I4 minus I3. Right? 8 multiply with I4 minus I3 equal to 0. Okay, and then after that, we can further simplify the equation so that you have negative 8I3 plus 2 plus 8 is 10. So plus 10I4 equal to negative 10. And then after that, we can further simplify the equation by divide the equation by 2. So you have negative 4I3 plus 5I4 equal to negative 5. So this is considered as the equation number 5. Okay, so you can solve the equation 4 and equation 5 by using the calculator. And then finally, you can get I3 is equal to 3.93 ampere and I4 is equal to 2.143 ampere. Okay, so once you find the value of I3 and I4, then you can find the value of I1, because I1 is equal to I2 minus 5, and I2 is equal to I3 minus 3I4. Okay, first of all, we need to find the value of I2 first. Okay, so from equation 3, I2 is equal to I3 minus 3I4. So we just know the value of I3 and I4. Then we can just substitute into it. So I2 is equal to negative 2.5 ampere. And then once you have your I2, then only you can find your I1. Okay, I1 is equal to I2 minus 5. So here is negative 2.5 minus 5 is equal to negative 7.5 ampere. Okay, so that's how you find the value of your mesh current. Okay, so that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay, bye.